Hi, my name is Scott Simpson, and today we'll be talking about naming ionic compounds. So this is generally sets or rules used in general chemistry to name ionic compounds. So naming ionic compounds. So first we have to understand what an ionic compound is. This is a compound that has ionic bonds in it, meaning you have a cation, positively charged particle, and you have a negatively charged particle called an anion. So we've got a cation, anion, and then there's an electrostatic interaction between those two to cause that attraction. Now what's another way we know? We can look at what are called differences in electronegativity. So electronegativity is the ability of an atom to withdraw electron density while participating in a chemical bond. So it's the pull that that atom has on that electron density. Most of the time, most ionic compounds can be thought of as a metal interacting with a non-metal. Okay. So, for example, NaCl. That's an example of a metal interacting with a non-metal. And it has the name sodium chloride. It's one of the most famous ionic compounds because that is what table salt is made out of. A lot of students tend to know that. However, what are the general rules when it comes to naming? Well, first you have the more positively charged particle. It usually follows, you have cation name followed by anion name. If we want to get a little more specific, we have the metal, so whatever metal we're talking about, or if it's a transition metal, one of those ones in the D block, such as iron, cobalt, nickel, and so on, or transition metal. And then you indicate its oxidation state, or the charge it would have, assuming a completely ionic interaction, in Roman numerals. So you have oxidation state. Okay, then for the anion name, if you have an individual element by itself, you usually have the element name, but you end in a suffix with "ide." IDE. Or you go with a polyatomic anion name, or polyatomic anion. So these are things like carbonate, sulfate, chlorate, and so on. Additionally, we can have polyatomic cation. Polyatomic cation name. Or when we're considering naming the cations. Okay, let's look at a couple of examples of these. We got KCl. Okay, K, elemental symbol for potassium. We have potassium. Cl, chloride, or excuse me, in this case it's the elemental symbol for chlorine. That ene changes to an ide, so we get potassium chloride. E, what about MgCl2? In this case, a lot of students are tempted to have to want to put in a dye or a prefix for the number of elements that are contained in here. With ionic compounds, you don't have to do that. It's assumed you know their charges and you know what their formula is going to be. Not very friendly to those who are first starting out on how to name these things or use these things. Chemists are kind of jerks that way. We got magnesium. Ooh, spelling, I'm terrible at spelling. Magnesium chloride. Okay. C. Let's look at one that's a little more complicated. CO CO3. Okay, in this case, we have a transition metal. We have to determine what its oxidation state is. A lot of times this comes from memorization of the different transition metals. The other way you can do it is you can look at what anion it's paired up with. This is paired up with carbonate. So we know carbonate, CO3, has a -2 charge. That comes from a list of polyatomic ions that you should know by this point when trying to name things. Okay, now, there's some charge here on that cobalt. We don't know what it is right yet, but we do know it has to balance out with that -2 to result in a 0 charge because this complex has no charge. So this has to be in a +2 state. Knowing that, since it's a transition metal, we have to indicate its oxidation state after the element name in Roman numerals. So this one would be cobalt 2. Then we have the anion, the polyatomic anion carbonate. Let's do one more, one that's a little more difficult. FeClO2. Actually, let's do 3. O3. Okay. This one, very similar to our previous example. We have to figure out the oxidation state on that iron. We don't know it. This polyatomic ion is known as hypochlorite. It has a -1 charge, and there are 3 of them. Since there are 3 -1 charges, whatever is on that iron, it has to balance out with -3. So in this case, it's a +3. Therefore, the name of this compound is iron 3 hypochlorite. So naming tends to be very difficult for students in general chemistry. What I suggest to do is to play around, guess what you think the name of something will be, punch it into Google, see if it matches up. There are other forms that you can, ways to study for this. Making flashcards is very helpful. A lot of my students use the app called Cram, and that can help you out quite a bit too. So just keep practicing, keep trying to memorize those things. If you have any questions or any comments, please leave them below, and thank you.